Hello and welcome. This video will cover securing multiple accounts with the AWS Organizations service. AWS Organizations is an account management service that enables you to consolidate multiple AWS accounts into an organization that you create and centrally manage. AWS Organizations is first mentioned for consolidated billing. Here, the focus is on the security features that the service provides. One helpful security feature is that you can group multiple accounts into organizational units called OUs and attach different access policies to each OU. Policies in AWS Organizations are called service control policies. For example, if you have accounts that should only be allowed to access certain AWS services, you can put those accounts into one OU. Then you can define a policy that blocks OU access to services that do not meet those requirements. Finally, you attach the policy to the organizational unit. This is basically a way to apply permissions to multiple AWS accounts at the same time. In the same way that identity and access management handles groups and policies for users, AWS Organizations handles groups and policies for multiple AWS accounts. This will allow you to have a separate account for each department or team and still represent your business as a single logical unit. Another security feature is that AWS Organizations supports identity and access management. AWS Organizations expands that control to account level if needed by giving you control over what users and roles in an account can do, similar to what IAM does. This is above and beyond the control of what a group of separate accounts can do. Here's a closer look at the service control policy feature of AWS Organizations. Service control policies offer central control over the maximum available permissions for all accounts in your organization, enabling you to ensure that your accounts stay in your organization's access control guidelines. Service control policies are available only in an organization that has all features enabled, including consolidated billing. Service control policies are not available if your organization has enabled only the consolidated billing feature. Service control policies are similar to identity and access management permission policies, and they use almost the same syntax. However, service control policies never grant permissions. Instead, service control policies are JSON syntax policies that specify the maximum permissions for an organization or OU. Attaching a service control policy to the organization root or an organizational unit defines a safeguard for the actions that accounts in that organization root or organizational unit can actually do. However, it is not a substitute for well-managed identity and access management configurations within each account. You must still attach identity and access management policies to users and roles in your organization's accounts to actually grant permissions to use them. AWS Key Management Service, or KMS, is a service that enables you to create and manage encryption keys and to control the use of encryption across a wide range of AWS services and your applications. AWS KMS is a secure service that uses hardware security modules to protect your keys. AWS KMS also integrates with AWS Cloud to provide you with logs of all key usage to help meet your regulation and compliance needs. Customer master keys are used to control access to other keys that encrypt and decrypt your data. You can create new master keys when you want, and you can manage who has access to these keys and which services they can be used with. You can also import keys from your own key management infrastructure into the AWS KMS service. AWS KMS integrates with most AWS services, which means that you can use AWS KMS master keys to control the encryption of data stored in most AWS services. Amazon Cognito provides solutions to control access to AWS resources from your application. You can define roles and map users to different roles so your application can access only the items that are authorized for each user. Amazon Cognito uses common identity management standards, such as the Security Assertion Markup Language, or SAML, version 2.0. SAML is an open standard for exchanging identity and security information with applications and identity service providers. Applications and identity service providers that support SAML enable you to sign in by using your corporate directory credentials, such as your username and password from Microsoft Active Directory. With SAML, you can use single sign-on to sign into all your SAML-enabled applications by using a single set of credentials. Amazon Cognito helps you meet multiple security and compliance requirements, including requirements for highly regulated organizations such as healthcare companies and merchants. AWS Shield is a managed distributed denial of service attack protection service that safeguards applications that run on AWS. It provides always-on detection and automatic mitigations that minimize application downtime and latency, so there's no need to engage AWS support to benefit from DDoS protection. AWS Shield helps protect your website from all types of DDoS attacks, including infrastructure layer attacks like User Datagram Protocol or UDP floods, state exhaustion attack like TCP SYN floods, and application layer attacks like HTTP GET or POST floods. AWS Shield Standard is automatically enabled on all AWS customers at no additional cost, while AWS Shield Advanced is an optional paid service. AWS Shield Advanced provides additional protection against more sophisticated and larger attacks for your applications that run on Amazon EC2 instances, Elastic Load Balancers, Amazon CloudFront, Amazon Global Accelerator, and Amazon Route 53. AWS Shield Advanced is available to all customers. However, to contact the DDoS response team, customers need to have either business or enterprise support. Thanks for watching. We'll see you on the next video. Hello and welcome. This video will cover securing data on AWS. Data encryption is an essential tool to use when you want to protect your data. Encryption takes data that is legible and encodes it so that it's unreadable to anyone who does not have access to the secret key that was used to encode it. Even if an attacker gains access to your data, they cannot make sense of it. Data at rest refers to data that is physically stored on disk or on tape. It is not moving, it's simply stored. You can create encrypted file systems on AWS so that all your data and metadata is encrypted at rest by using the Open Standard Advanced Encryption, AES 256 encryption algorithm. When you use AWS KMS, encryption and decryption are handled automatically and transparently so that you do not need to modify your applications. If your organization is subject to corporate or regulation policies that require encryption of data and metadata at rest, AWS recommends enabling encryption on all services that store your data. You can encrypt data stored in any service that is supported by the AWS Key Management Service. Data in transit refers to data that is moving across the network. Encryption of data in transit is accomplished using Transport Layer Security, or TLS 1.2. This is an open standard and uses AES 256 cipher. TLS was formerly called SSL. AWS Certificate Manager is a service that enables you to provision and manage the deployment of SSL and TLS certificates for use with your AWS services. SSL or TLS certificates are used to secure network communications and establish the identity of websites over the internet. Also, you can establish the identity of resources on private networks. With AWS Certificate Manager, you can request a certificate and then deploy it on an AWS resource, such as load balancer or CloudFront distributions. AWS Certificate Manager also handles the certificate renewals. Web traffic that runs over HTTP is not secure. However, traffic that runs over secure HTTP or HTTPS is encrypted by using TLS or SSL. HTTPS traffic is protected against eavesdropping and man-in-the-middle attacks because of the bidirectional encryption of the communication. AWS services support encryption for data in transit. Two examples of encryption for data in transit are shown. The first example shows an EC2 instance that has mounted an Amazon EFS shared file system. All data traffic between the instance and Amazon EFS is encrypted using TLS or SSL. To learn more, visit the AWS website. The second example shows the use of AWS Storage Gateway, a hybrid cloud storage service that provides on-premise access to AWS Cloud Storage. In this example, the storage gateway is connected across the internet to Amazon S3, and the connection encrypts the data in transit. By default, all Amazon S3 buckets are private and can be accessed only by users who are explicitly granted access. It is essential to manage and control access to Amazon S3 data. AWS provides many tools and options for controlling access to your S3 buckets and the stored objects. To protect an S3 bucket, you can use Amazon S3 block public access. This overrides any other policy or object permission and is enabled by default when you create the bucket. This feature provides a straightforward method for avoiding unintended exposure of Amazon S3 data. You can also write identity and access management policies that specify the users or roles that can access specific buckets and objects. This method was discussed in detail earlier in this module. There are called resource policies. Typically, resource policies or bucket policies are used when the user or system cannot authenticate by using identity and access management. Bucket policies can be configured to grant access across AWS accounts or to grant public or anonymous access to Amazon S3 data. If bucket policies are used, they should be written carefully and tested fully. You can specify a deny statement in a bucket policy to restrict the access. Access will be restricted even if the users have permissions that are granted in an identity-based policy that is attached to the user. Setting access control list on your buckets is another way to protect them. ACLs are less commonly used because ACLs predate identity and access management. If you do use ACLs, do not set the access that is too open or permissive. AWS Trusted Advisor provides a bucket permission check feature that is a useful tool for discovering if any of the buckets in your account have permissions that grant global access. Thanks for watching. We'll see you in the next video. Hello and welcome. This video will cover working to ensure compliance. AWS engages with external certifying bodies and independent auditors to provide customers with the information about the policies, processes, and controls that are established and operated by AWS. Compliance specifies the requirements for establishing, implementing, maintaining, and continually improving an information security management system. Certification requires development and implementation of a rigorous security program. The Information Security Management System defines how AWS manages security in a holistic and comprehensive manner. AWS also provides security features and legal agreements that are designed to help support customers with common regulations and laws. One example is the Health Insurance Portability and Accountability Act, or HIPAA. AWS Config is a service you can use to assess, audit, and evaluate the configuration of your AWS resources. AWS Config maintains a history of your AWS configuration and allows you to define who can change what and where. AWS Config does this by continuously monitoring and recording your AWS resource configurations. With AWS Config, you can automate the evaluation of recorded configurations against a set of rules. You can also review changes in your configuration and relationships between AWS resources. You can review detailed configuration histories and determine your overall compliance against the configurations specified in your internal guidelines. Doing this comparison simplifies compliance, auditing, security analysis, change management, and operational troubleshooting. As you can see in the AWS Config dashboard image shown here, AWS Config keeps an inventory listing of all resources that exist in the account, and it then checks for configuration rules. Non-compliant resources are flagged. This alerts you to configuration issues that you need to address in the account. AWS Config is a regional service. To track resources across region, you need to enable it in every region that you want to use. AWS Config also offers an aggregator feature that can show resources across multiple regions and even multiple accounts. AWS Artifact provides on-demand downloads of AWS security and compliance documents. You can submit the security and compliance documents to your auditors to demonstrate the security and compliance of your AWS infrastructure and services. You can also use these documents as guidelines to evaluate your own cloud architecture and assess the effectiveness of your company's internal controls. AWS Artifact only provides documents about AWS. AWS customers are responsible for developing or obtaining documents that demonstrate the security and compliance of their applications. You can also use AWS Artifact to review, accept, and track the status of AWS agreements, such as the Business Associate Agreement, or BAA. A BAA typically is required for companies that are subject to HIPAA to ensure protected health information. With AWS Artifact, you can accept agreements with AWS and designate AWS accounts that can legally process restricted information. You can accept an agreement on behalf of multiple accounts. To accept agreements for multiple accounts, use AWS Organizations to create an organization. Thanks for watching. We'll see you on the next video. Welcome back. It's now time to review the module and wrap up with a discussion of a practice certification exam question. In summary, in this module, you learn how to recognize the shared responsibility model, identify the responsibility of the AWS and customer, recognize identity and access management users, groups, and roles, describe different types of security credentials in IAM, identify the steps to secure a new AWS account, secure AWS data in transit and at rest, and finally, describe AWS compliance programs. Let's look at a sample certification question. Which of the following is AWS's responsibility under the AWS Shared Responsibility Model? The keywords to recognize are AWS's responsibility, which is what you need to find from the list of options. AWS Shared Responsibility Model, which references the model that was discussed earlier in this module. The correct answer is B, maintaining physical hardware. Thanks for watching. See you on the next video. Hello, and welcome to Module 5. This is called Networking and Content Delivery. This module will address the following topics. For networking, we will discuss networking basics, as well as Amazon VPC networking and security. For content distribution, we will discuss Amazon Route 53 and Amazon CloudFront. We include a demonstration that will show you how to use the VPC wizard to create a VPC with a public and a private subnet. A lab will have you use the VPC wizard to build a VPC and launch a web server. Finally, a knowledge check will be used to test your understanding of the key concepts that are covered in this module. After completing this module, you should be able to recognize the basics of networking. You should be able to describe the features of Amazon VPC and design a basic VPC architecture. Understand what are network security groups, as well as network ACLs. Identify the fundamentals of Amazon Route 53 and recognize the benefits of Amazon CloudFront. We're ready to go. Let's get started. Hello, and welcome. This video will cover basic networking concepts that will provide the necessary foundation for learning about Amazon VPC. A computer network is two or more machines that are connected together in order to communicate. A network can be logically partitioned into subnets. Networking requires a networking device such as a router or a switch. This connects all the machines together and enables communication between them. Each machine in a network has a unique Internet Protocol address assigned to it. An IP address, as it is known, is a unique number assigned to a machine in order to identify it uniquely. An IP address is similar to a phone number. It has to be unique. The IP number is expressed as a 4-decimal number separated by dots. Machines convert that decimal number to binary format in order to use it. For the IP address 192.0.2.0, each of the 4 dot-separated numbers of the address represents a maximum of 8 bits. This means that each of the 4 numbers can be anything from 0 to 255. The combined total of the 4 numbers for an IP address is 32 bits, in binary format. A 32-bit IP address is called an IPv4 address. IPv6 address also exists and use 128 bits. IPv6 addresses can accommodate more user devices and were invented to compensate for the fact that IPv4 addresses are in short supply. An IPv6 address is composed of 8 groups of 4 letters and numbers that are separated by colons. Each of the 8 colon-separated groups of the IPv6 address represents 16 bits. That means each of the 8 groups can be anything from 0 to FFFF. The combined total of the 8 groups for an IPv6 address is 128 bits in binary format. A common method to describe networks and groups of IP addresses is classless interdomain routing, or CIDR. A CIDR address is expressed as an IP address, which is the first address of the network. It's followed then by a slash character. The number after the slash character tells you how many bits of the routing prefix must be steady and allocated for the network identifier. The bits that are not fixed are allowed to change. CIDR is a way to express a group of IP addresses that are consecutive to each other. In this example, the CIDR address is 192.0.2.0/24. The last number, 24, tells you that the first 24 bits must be fixed. The last 8 bits are flexible, which means that 256 IP addresses are available for the network. They go in range from 192.0.2.0 all the way to 192.0.2.255. So basically, the 4th decimal digit is allowed to change from 0 to 255. The OSI model is a conceptual model that is used to explain data as it travels over a network. It consists of 7 layers and shows the common protocols and addresses that are used to send data at each layer. For example, hubs and switches work at layer 2, the data link layer. Routers work at layer 3, the network layer. The OSI model can be used to understand how communication takes place in the cloud and in basic networking. Thanks for watching. We'll see you in the next video. Welcome back. Many of the concepts of a physical network apply to cloud-based networks as well. In the cloud, much of the complexity of setting up a network has been abstracted without sacrificing control, security, and usability. This video will introduce Amazon Virtual Private Cloud, or Amazon VPC. Amazon Virtual Private Cloud is a service that lets you provision a logically isolated section of the AWS Cloud called VPC. It is your very own private space in the AWS Cloud. You land virtual machines and other resources inside of VPC. Amazon VPC gives you control over your virtual networking resources, including the selection of your own IP address range, the creation of subnets, the configuration of route tables, and the creation of network gateways. You can use both IPv4 and IPv6 in your VPC for secure access to resources and applications. You can also customize the network configuration for your VPC. For example, you can subdivide your VPC into subnets and create a public subnet for your web servers that can access the public internet. You can place your backend systems, such as database or application servers, in a private subnet with no public internet access at all. Finally, you can use multiple layers of security, including security groups and network access control lists, to help control access to Amazon Elastic Compute Cloud, Amazon EC2 instances in each subnet. Amazon VPC enables you to provision VPCs. A VPC is a virtual network that is logically isolated from other virtual networks in the AWS Cloud. A VPC is dedicated to your account. VPCs belong to a single AWS region and can span multiple availability zones. After you create a VPC, you can divide it into one or more subnets. A subnet represents an isolated segment of your VPC with its very own range of IP addresses. Subnets belong to a single availability zone. You can create subnets in different availability zones for high availability. Subnets can be public or private. Public subnets have direct access to the internet, but private subnets do not. IP addresses enable resources in your VPC to communicate with each other, and resources over the internet as well. When you create a VPC, you assign an IPv4 CIDR block, meaning a range of private IPv4 addresses to it. After you create a VPC, you cannot change the address range, so it is important that you choose it carefully. The largest IPv4 CIDR block you can choose is /16, which gives you a total of 65,536 possible addresses. The smallest IPv4 CIDR block is /28, which gives you a total of 16 possible addresses for your VPC. It is important to remember this maximum and minimum blocks that you can actually utilize. They are hard limits, so they cannot be broken. You can associate an IPv6 CIDR block with your VPC and subnets and assign IPv6 addresses as well from that block to resources in your VPC. IPv6 CIDR blocks have a different block size limit. The CIDR block of a subnet can be the same as the CIDR block for a VPC. That means that a subnet can be as large as the entire VPC. But you can also use a subnet with its own CIDR block to subdivide your VPC. This structure enables the definition of multiple subnets. If you create more than one subnet in a VPC, the CIDR blocks of the subnets cannot overlap. You cannot have duplicate IP addresses in the same VPC. When you create a subnet, it requires its own CIDR block. For each CIDR block that you specify, AWS reserves 5 IP addresses within that block, and these addresses are not available for you to use. AWS reserves the following 5 IP addresses for different reasons. The first one is network address. The second one is for VPC local routing and internal communications. The third one is for the domain name system resolution. The fourth one is reserved for future use. And the fifth one is the network broadcast address. For example, suppose that you create a subnet with an IPv4 CIDR block of 10.0.0.0/24. This, in theory, gives you 256 total IP addresses. The subnet has 256 IP addresses, but only 251 are actually available because 5 of them are reserved by AWS. When you create a VPC, every virtual machine in that VPC gets a private IP address automatically. You can also request a public IP address to be assigned to a virtual machine when you create the instance by modifying the subnet's auto-assigned public IP address properties. An elastic IP address is a static public IPv4 address. You can associate an elastic IP address with any instance or network interface for any VPC in your account. With an elastic IP address, you can mask the failure of an instance by rapidly remapping the address to another instance in your VPC. Associating the elastic IP address with the network interface has an advantage over associating it directly with the instance. That means that you can move all the attributes of the networking interface from one instance to another in the event of a failure in just a single step. Additional costs may apply when you use an elastic IP address, so it is important to release them when you no longer need them. An elastic network interface is a virtual network interface that you can attach or detach from an instance in a VPC. A network interface attribute follows it when it is reattached to another instance. When you move a network interface from one instance to another, network traffic is redirected to the new instance. Each instance in your VPC has a default network interface. That is called the primary network interface. It is assigned a private IPv4 address automatically, and it is within the IPv4 address range of your VPC. You cannot detach a primary network interface from an instance. You can create and attach an additional network interface to any instance in your VPC. The number of network interfaces that you can attach changes by the instance type that you're utilizing. A route table contains a set of rules called routes that directs network traffic to and from your subnet. Each route specifies a destination and a target. The destination is the CIDR block where you want traffic from your subnet to go. The target is the processing resource where the traffic is sent through. By default, every route table that you create contains a local route. This is for internal communications within the VPC. You can customize route tables by adding additional routes. You cannot delete the local route table entry. That is used for internal communications and is steady and unchangeable. Each subnet in your VPC must be associated with a route table. The main route table is the route table that is automatically assigned to your VPC. It controls the routing for all subnets that are not explicitly associated with a custom route table. A subnet can be associated with only one route table at a time, but you can associate multiple subnets to the same route table. That means that the mapping between subnets and route table is a one-to-one mapping. despite the fact that you can use the route table for multiple subnets. Thanks for watching. We'll see you in the next video.